two masses and a spring. We have a small block of mass M1 over here. It rests on M2 but is not attached to it. Block M2 is placed on a horizontal frictionless surface. The maximum friction force between the blocks, that's right there between M1 and M2, is F. A spring with a spring constant K is attached only to the large block M2 and the wall. Determine the maximum horizontal acceleration of block M2 where M1 doesn't slip on its surface. Determine the maximum displacement A for simple harmonic motion if the blocks move together. And C, you pull the two blocks to the right to the maximum amplitude found in part B and released. Describe the friction force between the blocks during the first half of the period of oscillations. Not done with the problem statement. We have a little bit more. Part D. The two blocks are pulled to the right a distance greater than the maximum amplitude found in C and then released. Determine the magnitude of the acceleration of M1 at the instant when the blocks are released from this new position, and also determine the magnitude of the acceleration of M2. Determine the maximum horizontal acceleration of block M2 where M1 doesn't slip. The maximum acceleration of block M2 occurs when the acceleration of block M1 equals the acceleration of block M2. Then the blocks will move together without slipping. The only force acting on block M1 when it has its maximum acceleration is the friction force. Okay, the spring force is only acting on M2. So we can say that A1 max equals A2 max, which is what we're trying to find. So what is A2 max? That will equal A2, which equals A1. And the only force acting on A1 is F. So the acceleration is F over M1, right? We're just dealing with the free body diagram for mass 1. So yes, the answer is that simple. It's F over M1. Find the maximum displacement A for simple harmonic motion of the two blocks if they move together. Well, here's what we have from the previous section, part A. We found the acceleration, it's F over M1. Now we're going to go ahead and use Hooke's law, F equals Kx, and our maximum spring force acting on the system of two masses moving together, that will occur when we are at maximum displacement. So we have the equation here, F max is equal to Ka. Now what is the force, the maximum force? That's going to be Ma, but be careful. We're dealing with these two as a system. They're moving together, so we need both masses in there. M1 plus M2 times A max is equal to Ka. We rearrange that to solve for the maximum displacement A, because that's frankly what we're looking for. And what do we have in here? M1 plus M2 are given, K is given. A max is not given, but we already solved for that. That's over here. That's F over M1. So here is our expression for the amplitude of the system when the two masses move together. Now you have to write something. The AP exams are doing more and more of this lately. So we pull the two blocks to the right to the maximum amplitude found in part B and released. Describe the friction force between the blocks during the first half of the period of oscillation. Well, the friction force starts with its maximum magnitude F. Okay. It decreases to 0 at the quarter period of oscillation, then will increase in the opposite direction until it reaches a maximum amplitude F again when it completes one half of a period. The force varies sinusoidally with the acceleration. Determine the magnitude of the acceleration of M1. And what have we done? We've pulled them to the right a distance greater than the maximum amplitude for them to stay together and then released. So even though the blocks are pulled a distance greater than the maximum amplitude for them to stay together, the spring force certainly increases, right? If they're all the way out here, the more you stretch the spring, the greater the F equals Kx will be. But the friction can't increase anymore. It already is at its maximum value. So A1 will still just be F over M1. Determine the magnitude of the acceleration of M2 at the instant when the blocks are released when you pull them out further than the amplitude where they'll stay together. Well, you have two forces acting on M2. You have the maximum friction force, which stays constant, that can't get any bigger, and the spring force, which of course can get as big as however far you pull it out. So the sum of the forces will be M2A2, because we're just interested in mass 2. And if we pulled it out to this new distance A prime, where A prime is greater than the maximum amplitude found earlier, that force will be Ka prime, which will be pulling it back, and the friction force will be acting in the opposite direction, and that will be F. And we're just doing it, the free body diagram here is just for M2. So the acceleration of block 2 will be Ka prime minus F divided by M2.